Good morning, class. Hey, this is the third section that we've done on rational expressions. We're going to simplify complex fractions. Here's a complex fraction here on this slide. If you take a look at this complex fraction, basically is looking at a fraction divided by a fraction. So, in essence, really what I could do is I could rewrite this as 2/3 divided by 4/5 and make it more customary, or the way that we've used to seen division problems. Remember that division bar in the middle is nothing more than a division sign, but it's set up as a single term. So it's a fraction divided by a fraction, or in the rational expression form. Okay, so what we do with these, if you recall, what we do with this is we're going to flip the second term and switch this division sign to become a multiplication sign. So then it's going to be 2/3 times 5/4, which would give me 10/12, and then I can reduce, divide by 2, I would get 5/6. And so I get a 5/6 as a result from this complex fraction. Now, you got to remember, this piece right there is critical. Okay, when you take when you take this division bar and write it as a division sign, it's going to make this a lot simpler to look at. We're going to do the very same things with rational expressions. We're going to see the division, see the division bar, and write it as a division sign. Okay, so I'm writing that down here, but I'm also going to do one other thing. On some of these fractions, I'm going to ask you to simplify the fractions. So as we look at this next slide, we have a compound numerator that has two terms, and a compound denominator that also has two terms. Okay, basically what I want to do on this is I want to take and I want to find the least common denominator for every term, which means that we're going to look at each of the denominators, and even though there's not a denominator under that 1, we'll look at that as a denominator of 1. Okay, and the least common denominators is, remember, it's the common times the non-common. It's a product. So our common factor here is a y. Our non-common factor would be a 1 and an x. Well, what is y times 1 times x? Well, very simply, it's xy. So what we're going to do is we're going to take this whole expression and multiply the least common denominator by every term that's in that expression. Okay, I'm going to switch back to black. And I'm going to start with my expression as 1 over x plus x over y. Notice I'm spacing it out a little bit. Divided by 1 over y plus 1. And I'm going to multiply, now I'll go back to the blue, I'm going to multiply by xy on each of these terms. Okay? And then I'm going to put that guy over 1. Alright? So as I multiply by xy, I would cancel out my x term in the denominator and the x term in the numerator, and I would be left with this 1 times y, which gives me y. That's all. Or y over 1. Okay? On this one, when I multiply this by xy, I can cancel out the y's. Essentially what I'm doing by multiplying by the least common denominators, I'm wiping out all the fractions in the numerator, all the fractions in the denominator. Every one of them will be wiped out because of this least common denominator. So I'm left with a y here in that term. Now, let me go to a highlighter, try this. What I'm left with here is x times x, which would give me plus x squared. Okay? And that's it, or over 1 if you want. Divided by, here's that division bar. Okay? We're going to leave it there for the moment. Again, cancel out the y's here, and I'm left with 1 times x, which is x, plus, now when I multiply these, I get xy. All right, so I'm going to change to a red, and I'm going to come down, and this will give me x squared plus y over x plus xy, or x times 1 plus y. All right, now I can't reduce that at all. Okay, now I'm not going to worry too much about what's limited or my restrictions. We're not going to go there. We're just going to say, okay, this is a simplified form coming from this original expression up here that I'm highlighting. Okay, so x squared plus y over x times, and I could even change that to y plus 1, get that in its standardized form. All right, and then that's going to give me my simplified form. And you may look at that and say, that doesn't look simpler, but it really is when you stop and think. I had fractions in my numerator and fractions in my denominator, and here I have simply one fraction. I have, well, let's do the last example here. I'm going to do one more example down below. This is a x over 1 over x plus 1 over y. And again, I'm going to write this a little larger, so this would be x over 1 over x plus 1 over y. And let's just use the same idea. Let's find that least common denominator. So we're going to look at our denominators, and if you didn't think it through, or you didn't, if you're guessing ahead, I should say, that would be xy. So we're going to do the same thing. We'll multiply by xy, xy, xy. Every term gets multiplied by that xy. And it's all because of the fractions in the denominator downstairs. All right? We want to get rid of this guy and this guy. Now here's how we're going to do it. Let's go to a different color. We'll go to purple. And I'm going to cancel out the x here and the x there, which leaves me 1 times y. All right? So in the denominator now I've got a y over here plus, okay, using this plus sign. And then on this one, the y's cancel. I've got 1 times x. So I have an x left over. Upstairs, I have x times xy, which is x squared y. And that's it. Okay? Now, you can't cancel out the y's. You might look at this and say, hey, do these guys cancel? And no, they don't. Why is that? Because this is a monomial upstairs, and this is really a binomial downstairs. And you can't cancel a monomial by a binomial if it's in its simplified form. It has to be equivalent factors, and this binomial is not factored. It's not factorable. You could take a 1 out, but you could take a 1 out upstairs too, and they would cancel. But we don't really work with 1s, do we? So my simplified form is going to be x, oops, let's get that into numbers, x squared y over, and I'll put x plus y. I'll put it in that form so the x's are out front. And don't forget, that is a binomial. If you want to leave it in parentheses, that may keep you from trying to break it up. There is my simplified form. That is a simpler form, okay? And that's it. Guys, you're going to struggle a little bit with this. Remember, if you need to, take it apart. If it's numeric, I liked what I did with the original up here with dividing it, but when you get to fractions, you are going to have a problem. So you're going to want to look at this example and then this example. They are going to stay fairly simple. In your homework, I think we're going to stick with this kind right here where it's more simple. Hey, I hope you do well with this. Have a great day. I'll talk with you later. Google group tomorrow at 11:30 again. All right, see ya. Bye.